Today, I thought I would make a kind of an Ask Us Anything episode, sort of a Q&A for folks, because I've been noticing a bunch of our active viewers who are watching the YouTube live streams have been asking a couple of questions, and I thought I'd just go ahead and compile some of those up and create an episode on it, kind of dedicated to itself, and we'll periodically have those as as we go on throughout the years. Couple announcements before we start. One is there are a couple of books that I'm proposing that we kind of go through. One of which we kind of introduced prior to our holiday break. One was The Art of the Meta Object Protocol. I've decided that when we started to introduce DMAP, that a good way of actually probably going through it, and this was kind of agreed based on some discussions with other folks that are on, to go through the Meta Object Protocol is to read AMOP, because AMOP is kind of the reference on the Meta Object Protocol and how CLOS is kind of implemented. Another book that I'm kind of proposing, and I think right now we're going to go ahead and go through it, is Lisp in small pieces, but not all of it, just because Lisp in small pieces is how to write Lisp compilers, and one thing it covers is R4RS, which is scheme, and specifically there are topics in there, many of which that we kind of brought up in various discussions, one on garbage collection, one on consing, things like setting up your basic eval and REPL stuff. Lisp in small pieces goes through a lot of that in far more detail, and it comes up with a couple of examples that I think going through would be kind of useful. Today,
did you guys hear any of that?
Could you hear that, or
could you guys hear any of what was going on for me? Just hoping I didn't interrupt anything.
No.
Good. Okay. Anyway, sorry. Carry on.
So
I'm back now.
So to get things started, there was a topic, a specific question that was asked by one of our viewers on just common Lisp development. He noticed that he was watching our Sly and SpaceMax video from a few months back, and his question was, let me just pull it up here just so I can get it right, is that where was it? It was this one. Okay. The Sly layer on GitHub is archived, and I assumed it's not actively developed anymore.
Yes, I used to maintain that. I stopped maintaining it just because I no longer use it, and the other people that were helping maintain it, such as Elijah here, no longer use it. So I heard it does have a couple bugs, but I also heard that for some people they were solved with recent SpaceMax updates. So I'm not sure if it works.
Yeah,
currently.
I actually have installed it on the SpaceMax installs of a few friends of mine in like the past couple months, and it still worked fine. I mean, like more or less. It hasn't like broken, but you do need to make sure that you're on develop. And
yeah, one thing to know is there's a few forks that exist for it. Please don't use them because some of them are simply wrong. They treat Common Lisp Sly as a package rather than a layer, which is just to get around some error that popped up, which is completely wrong, and that error no longer exists anyway. So don't use any other branches, even though they're more ahead than upstream. You're just going to run into problems.
Yeah.
The upstream, while archived, it seems to work well for a lot of people, so I would just stick to that.
I'm like, honestly, it's just like, I don't think either of us would be opposed to somebody officially properly forking it and then maintaining it and asking us for the occasional assistance in understanding how or why things are set up the way they are. But neither of us are really interested in maintaining it ourselves at this point, just because we have other stuff that we're trying to keep up with.
Not that it's difficult. I encourage anybody if they want to maintain it. It's only about 100 and 150 lines or so. It's nothing.
Yeah, honestly, it really just, it was the part of the reason why it still works is that there really isn't a whole lot there to break, right? The things that, there are some features that might be nice to have, I suppose, and SpaceMax's API is a moving target, and so I'm sure eventually things are going to bit rot a bit. But for the most part, it really is just a light maintenance thing. And if someone wants to take that on, I at the very least would definitely be up for, helping answer questions or even the odd fix if someone brings it to my attention, depending on time. It's just, I at least I don't have that time regularly, and so can't commit to actually being a maintainer.
Right. So one question a follow up he had was if the layer is not actively being developed right now, would a temporary fix be installing Slide via the package manager, or is because right now I think he goes on and says that he's still using the common Lisp layer in the meantime because it provides Slime by default, I guess. So
so the common Lisp Sly layer actually provides more than just Sly. It integrates with all the other SpaceMax packages that are nice to use for Lisp, such as like Lisp State and Clever Parens for structural editing.
And the reason for that is that you actually can't have both Sly and Slime installed at the same time. And the common Lisp layer, the regular one, which does all of that integration as well, pulls in Slime. And so you need to do, probably, if you wanted to go down that route, would be in your SpaceMax config, use the common Lisp layer, exclude Slime, pray that the layer still functions with Slime excluded, and then you could install Sly as an extra package in the extra packages list, and then you wouldn't get the comma commands, you wouldn't get the comma shortcuts, because those need to be defined by hand. We have definitions for them in the layer. And B, you probably wouldn't get, like, auto-completion might not quite work. I don't know for certain. I'd need to check. Like, a lot of things, like, it would quote-unquote work in the sense that you would get the highest, level of common Lisp integration that, anything that the common Lisp layer provides that isn't directly dependent on Slime, and you would have Sly installed, but it wouldn't be like having the common Lisp Sly layer, which actually integrates everything properly.
Okay.
Right. So that is kind of an option, but it's also kind of broken.
Okay.
Yeah, I would just, recommend, say it does bit rot and, somebody needs to fork it. Just look at the code. It's not much at all. Just look at the packages that are brought in. It brings in like 3 or 4 packages. So, I would
personally do is compare it against the regular common Lisp layer, and perhaps even look at how old versions of the common Lisp layer compare with the more recent version of the common Lisp layer, and how that compares with the common Lisp Sly layer. And if you just compare all of that, it should be fairly obvious what exactly has gone wrong. Because probably if something bit rots, it's because SpaceMax's API changed. And, it should be fairly obvious what that change will be, because it should be reflected in the mainline common Lisp layer, since they maintain that.
Okay.
Yeah, I'm actually surprised that it works so well still. The whole reason why it's no longer maintained is because I stopped using SpaceMax, and the whole reason I stopped using SpaceMax was because it's a moving target and it changes so much.
Yeah.
But it still works, so that's surprising.
But I haven't updated SpaceMax in a while, so my environment has kind of probably been stagnant for the last year, just because it works for me. I'm able to use the latest SBCL. I'm able to use the latest Sly, from what I can tell, because I actually installed Sly via, I think I do use your layer, but I thought I also used, I think I changed it so that I can use the Sly from Roswell, but I'm not entirely sure. But that's a different discussion altogether. I kind of Frankensteined my environment a little bit over the.
I see Jace has a fork of it right here. Jace, you have a fork with one commit on top of it that says "fix the thingy," whatever.
Oh yeah.
Whatever that means.
Yeah. Yeah.
Fix the
Yeah.
That's
thing.
the best commit message ever.
Oh yeah. Well, look at the actual diff. Honestly, it's
Oh yes. Oh,
I've actually
man.
forgotten that I have that commit. It's possible that it's a fix for something that's kind of important. I forget offhand. Oh no, so I'm one commit ahead, one commit behind. Because oh, that's right, the stupid sly fancy nonsense.
So, let me just get this one thing so we can get
Anyway.
the second topic of discussion, which is probably the bigger one. This isn't the first time I've seen this question, but there was a question on what was it? On writing, studying data structures and algorithms in Common Lisp. Now we talked about this a little bit before in the past, but I bring it up again just primarily because it was brought up in another discussion that I was having with someone else about Common Lisp and writing data structures inside Common Lisp. I started doing my own digging over the holiday break, and one library that I started going through, and then I realized that there were other libraries of that kind of nature on GitHub. Both Michael mentioned earlier that he was working on a similar type of library, was the CL Data Structures library created by, well, I don't know who created it. The person that wrote good, decent documentation on it is a person by an alias Sir Botka on GitHub. He actually has a series of documents, docs online that goes through the API reference, and he splits up the different libraries, packages that are inside the library that they created. To like go through, what's available. And this is kind of a fairly decent sized library from what I can tell. It includes things for convenient functions for file system design, kind of, I think, from the Alexandria kind of style, clustering threads, streaming algorithms, and so forth. But I wanted to bring this up just because, this is like the third or fourth time that, I've kind of been, this has been mentioned to me, and I myself have been trying to design data structures and trying to implement various algorithms, which mostly are focused on, compiled languages, at least if you look at the pseudocode from various references. And how to match that into the Common Lisp mindset so that you still get efficient code has always been a question of mine. So, folks who have been, playing around and implementing some of these things, any thoughts, how to go through this?
Sure.
Well, yeah, my first advice is to not worry really about performance when it comes to data structures, because a data structure, its primary purpose is to efficiently manage some kind of collection of data or whatnot. I would stick to class, with generic dispatch and everything, and especially when you're dealing with certain data structures like trees, where the performance really matters based on how many items you have, and it's still logarithmic. So, I mean, making that efficient isn't really going to buy you much. I mean, the more efficient you make code, the less readable and maintainable it is. There's just no way around that. Code can always be made more efficient. The question you want to ask is, do you want to sacrifice that readability when it's really not going to buy you much for, especially most data structures?
Yeah, really what it sort of comes down to is that an efficient data structure is efficient because of the complexity of operations on it, like the time or space complexity, big O, not the actual constant factors involved. And so it actually ends up being more a question of, have you actually faithfully implemented this data structure such that the operations on it satisfy the complexity constraints that give you the performance constraints that you care about.
Right.
Not so much.
And I'm sorry to interrupt. I was just kind of like, and this is kind of what I was trying to get at too as well, right? There's asymptotic complexity requirements, and sort of like guarantees that if you implement this data structure correctly, outside of benchmarking and maybe doing some tweaks here and there, you would get these. You should get these asymptotic runtimes, kind of guaranteed because of the way you laid out the data structure, in kind of implementing it that way in Common Lisp so that you can get those requirements has been the question of mine. Like, for example, there's being able to do things in a cons free way, right? Where does that make sense? How does that make sense? That kind of thing.
That's somewhat different, right? When you're talking about like non-consing, right? That's a completely different. Well, it depends a bit, but that's a different like constraint than when you're talking about regular just asymptotic time complexity, right? Especially given allocation in something like Lisp is generally pretty cheap, especially compared to like malloc and C. So I mean, it really depends on exactly what constraints you're giving yourself. Like, if you really do want to, if you want to talk about like a data structure that isn't going to cons, that's a very different kind of constraint than just the asymptotic time or space complexity of the data structure.
Okay.
So I guess it depends, like, what kinds of constraints you're looking for and what kinds of constraints you're caring about. Because, asymptotic time complexity is really specifically about what happens when you stress this data structure with large numbers.
Right.
Right. And non-consing is really kind of a non-consing data structure is really kind of that's a small size optimization.
That's a small okay.
Because you can't avoid consing. Eventually you have to cons because eventually you need more space to store the stuff in.
Right.
Yeah, the only way around it is to define everything up front at compile time, like pre-allocate arrays and everything.
Exactly. And so really well, it's possible that that's what you need to do. But the point is that, like, if you're talking about non-consing, that's a small size optimization. It may be a fairly large size for your case, but it's still a small size optimization. Eventually, you're going to be talking about sizes of input data that's larger than whatever rules you've set up that allow you to avoid consing on. You could talk about instead. For example, and this is like sort of the classic example for this is like resizing a vector, right? Mm-hmm. You resize a vector by doubling the actual storage, right? And the effect of that is asymptotically, the space complexity of the vector grows, or the space used up by the vector grows linearly.
Right, that's right.
Right, and so does the time complexity required asymptotically.
Right.
That's right. But that's sort of a different constraint, right? Now you're talking about
that's only on right. If you're increasing the capacity of the vector upon insertion, right? Like
Correct.
And so you have to think about and there are cheap optimizations that you can make that could, although it is technically growing linearly, asymptotically, from a runtime perspective, it will still look like you're getting constant insertion because behind the scenes you've allocated more memory than what you really needed.
Right. You're doubling the actual storage available.
Yeah, exactly.
Whenever you run out, yes.
So these are the kind of questions that I have when you're designing a data structure in Common Lisp. This is just conceptually before we start. I'm gonna show you like this API that at least that I've been looking at. But when you're designing it, do you guys have any sort of principles or practices?
There aren't really any tricks to it per se. At least I wouldn't say that there are. I'd say it all really depends very heavily on what data structure you're implementing and what asymptotic constraints you're trying to set for yourself.
Okay.
Like when I'm implementing a binary tree, I'm not going to be caring about too much about the exact allocations that I'm doing on it, apart from the fact that the operation itself should really only be touching, say, a factor of 2 of the path that I'm modifying in order to edit a given node.
Right.
Due to like rebalancing operations.
if you're implementing a balanced binary tree.
Right. Exactly.
So
I don't think much about unbalanced binary trees.
okay.
Yeah, they're kind of useless.
Yeah. There's like I don't care much about unbalanced binary trees. Whenever I talk about a
Speaking
binary,
of balanced trees, I did some experimentation with them recently, and a lot of people use red black. There's actually a balanced binary tree that came before red black called AVL.
Yes, that's
and
right.
It balances really, really well.
Yeah.
Way better than red black. I did some tests on
also
it.
spends a lot more time balancing.
Yes, but there's also the weak AVL, WAVL, which tries to bring the best of both worlds. But I did some tests on it, and the results I found, I inserted 1,000 integers sequentially from 1 to 1,000 into a red black, and then I measured the height of the tree, and it was always 13 or 14. Then I did it with AVL, and it was always 10. Now, mind you, the best height for a perfectly balanced binary tree is 10. So on a logarithmic scale, 10 to 14 is a huge change just for 1,000.
Well, so I mean, red black guarantees that you'll have a height somewhere between 10 and 20 for a tree of that size. Whereas AVL guarantees you'll have a height.
Best height. Best
right.
Yep.
Yes. Yeah. No, but I'm saying is like in the general case, right? A red-black tree guarantees that you'll have somewhere between 1 and 2 times the log base 2 of the number of nodes. That's one of the hard guarantees of how red-black trees are set up. AVL trees, if I remember correctly, it's a factor of 1 to 1.3 of the size. And it's possible that like a side effect of the exact way that you a side effect of how you've got yours implemented, that specific case happens to always come out to exactly 10, or it's possible, or any number of other little details. But if I remember correctly, the factors on an AVL is 1 to 1.3 log base 2 of n, as opposed to 1 to 2 log base 2 of n. And the reason for that has to do with the fact that an AVL tree only lets the 2 subtrees differ in height by at most 1, whereas a red-black tree lets them differ in height by at most a factor of 2. And so, yeah.
Yeah, I think it's like 1.32 something.
Yep.
So let me pull up Emacs and share my screen here. I think I'm set up here to play around with this library. But first, let me go ahead and show you guys the library itself. Give me just 1 second. I'm going to pull this out into its own window. So I don't have to deal with the nonsense of Jitsi. Share my screen. You don't mind if I take over the screen, do you, Elijah?
I'm not sharing my screen. I think Michael might be.
Oh, Michael, you're sharing.
Yeah. I am. I don't know why.
All right. I'm going to go ahead and share it. Okay. Let's go ahead and start up Sly here. Actually, before I share this one, let me share the first thing, which is application window. This one. So this data structure library that I've been playing around with, actually I've kind of been reading through the API reference first just to get an idea on what sort of things it has, just because there's a lot of them. Has a nice little breakdown of different library packages of algorithms that it implemented. One thing that was particularly interesting about this library that caught my eye, at least, is the use of trait classes. Now, I haven't seen traits being used in languages other than C++, so this might be a completely different trait than that. But my reading of this trait class, which talks about making them more functional and dealing with adding like type information on it. It makes it sound like that it's similar in at least concept. But this library has, a bunch of built-in functions for like, standard accumulate, hash join, group by, finding things like, extrema and all that. Some of these, I think, if I recall, are available also in Alexandria and in even probably in some cases Serapium, but I'm not sure.
So a couple questions I have.
Mhm.
Does it have any tree implementations? Am I duplicating work?
It looks like it actually has a hash array mapped try implementation, both a persistent and a mutable one. But I don't see any trees.
Yeah, I didn't see any trees when I looked at this.
And my second question would be, if it did have trees, does it allow duplicate keys? Because most textbook implementations explicitly forbid that.
Binary search trees don't allow duplicate keys. It's kind of a fundamental
Yes, they
limitation.
Do. Yes, they do.
Well, yes and no. It depends on a lot of little details about what exactly you mean by having a duplicate key.
Well, if you look at the Wikipedia entry, it specifically talks about binary search trees with duplicate keys.
So
it's not disallowed. It's usually disallowed in textbook, exemplary examples that try to simplify.
Stops you from putting duplicate keys, but like if you're talking about like a key value mapping tree, for example, then it's kind of nonsense to have duplicate keys.
Right.
And that's generally why people use binary search trees these days, is as key value mappings. If you're talking about like just a multi-set though, like if you're actually talking about a multi-set, then yeah, that would make sense.
Yeah, but a multi-set by definition allows duplicates, right?
Well, yes, that's why I said multi-set instead of set.
I'm just saying, like.
Well, yes, I'm saying that you could implement a multi-set using a BST if you wanted.
Right.
Yeah, I mean it's an ADT, so it depends on the use case, really.
Yeah.
The nice thing about this library, for me at least, was, and this is again me just going through its interfaces so far, is the nice it's leveraging class to generate essentially interfaces for different types of traits that you would want to have for a particular algorithm. So this is kind of what, if you use templates in C++, that you now with concepts being in the language in C++ 20.
Now look at this class hierarchy, okay? This is all generic dispatch. This goes about your performance question.
Yes. Oh, I know. I'm not saying that this is performant. I'm saying that this is why I bring up the question. Like, at some point, there's going to be an optimization done. If you do like optimize speed, I'm sure there's tree shaking happening behind the scenes somewhere where it flattens everything, recognizing that, wait a second.
Depends on the implementation.
Depends on the implementation. Okay.
Yeah,
the implementation define detail, but I would assume that there is a compiler out there that would do something.
Lisp works.
Yeah, Lisp works probably.
Yeah, or even maybe Allegro in that matter.
Maybe Allegro, yeah, but Lisp works.
Yeah, maybe Allegro. Just because, regardless, though, this is kind of where making generic algorithms becomes very, very useful, because now you could say, okay, we know these characteristics that we want to a particular container or class to have, or a particular data structure to have. But then, if you designed or implemented that data structure wrong, and based on the way it's laid out or whatever, or you're not leveraging a certain kind of like, I guess I'd say trick, but really it's really a common Lisp idiom to implement your data structures efficiently, you could end up, botching some of the performance guarantees, and then you'll blame Lisp for being slow, when really it's your implementation not following kind of Lisp idioms when you're implementing your data structures. But that's a question that I was kind of trying to get at when I was going through some of this. But besides this, I wanted to also showcase Michael's collection.
Please
library.
don't. Please don't. Please don't. It's
You can
horrible
show
as
off
of
mine
current.
if you want. No, there's only one thing that's up there right now. And
It's horrible as of current. Right now, I just have binary search trees and then specializations on that, such as red, black, and AVL, and a partially totally incorrect splay tree.
That's okay.
We could talk about mine if you want.
Yes, go ahead and go through yours. All right.
Okay.
That's
Yeah, github.com/jace97/ I forget what I even called it. You'll find it on my user page. Yeah. It's the only thing that I've committed to recently. It's not any of those. Go to repositories. Wow, I have 39 repositories. P-trees, that's the one.
P-trees.
Yes. It's a library of persistent trees.
It does something.
Yes, it does something.
It does something.
Okay, so I'm implementing the trees behind Clojure's persistent data structures.
Okay.
And I'm doing them with support for all of the things that Clojure's persistent data structures can do, like transients, because transients are cool. This particular thing is a library that does, this particular file does binary search trees using a join-based technique, right? So it turns out that you can implement unweighted or unbalanced, weight balanced AVL and red-black trees, all in terms of a single function called join.
Wow, really?
And split.
No. You can implement split using join.
Oh, okay.
Yes. You only need join. The join function is separate for each of them, but the join function is the only thing that needs to actually understand how your rebalancing algorithm works.
That's interesting.
So is this joiner a kind of like a closure that holds the function and some state? Okay.
Not much state, actually. Almost no state.
State. Okay, so it could be a pure function, but
it is effectively a pure function. The only thing that it holds on to is a reference to. Actually, does it hold on to anything? Scroll down for me, please. You'll find it when you get down to make weight balance, make WB. WB join. That's the one. It is a pure function. That's right. Okay. WB join is a pure function.
Okay. Nice. Yeah. Very nice.
Okay. So this is the function that does it. Okay. So what join does, right, is it takes two trees and a key, right? And the idea is that the key has to be greater than every key in the left tree and lesser than any key in the right tree. All right? And it makes a new tree which has both this new key value pair and all the items in both the two other trees you gave it. But it doesn't necessarily just do it by making a new node at the root, because you might have violated your balancing rules. And so it also does rebalancing to make sure the tree it gives you back is balanced.
Nice.
Right? And so this is the algorithm that does that right here. This is the algorithm that takes two trees and a key that's in the middle of them and gives you back a weight balanced tree that contains everything from all of that.
So if I want to implement red-black using your...
you just have to implement a red-black join.
Okay.
Question.
Yes.
What is this this hard-coded constant 0.29?
That's my alpha.
Your what now?
It's the ratio of a node to the of the weight of a node to the weight of its parent.
Okay.
On a balanced tree.
Okay.
All right. Okay. The weight of a node to the weight of its parent. Okay.
Yeah, on a balanced tree.
Okay.
The weight of a node.
This is what you're using. Has your metric to decide whether you have to rebalance or not, right?
Correct.
Okay.
Yep. If you scroll down a little further, join right. So join right. What it does is it does it where that's the one you run if the right tree is smaller than the left tree, right? And the way that it works is it goes down the right spine of the left tree. So it travels down the right child of the left tree until it finds a subtree on the right edge of the left tree, which is about the same size as your right tree. Does that make sense?
Okay.
That's what that first test is for. That's balanced size of left, size of right. That's saying, have I found a subtree, a rightmost subtree of the left tree, which is the same balance, which is balanced with the tree that I got passed in on the right side.
Interesting.
Right? And if so, it just makes a new node. Or rather, so actually scroll up a little again. This function is really hairy, honestly. This is a really hairy function right here.
Yeah, you have a labels inside a labels. That's kind of weird.
Yeah, I needed to, though.
Yeah, I kind of see why, but I've never seen anything
let's
like that.
go through this. Okay, so
so the first thing to understand is what a transient is.
Okay.
So a T tree is a transient tree, right? And you can only make modifications to a transient tree. You can't make any modifications to a persistent tree in my library. There are literally no functions for it. However, you can make a transient tree out of any persistent tree in constant time, and you can make a persistent tree out of any transient tree in constant time.
How do you guarantee the mutability of? I mean, I know your API doesn't provide it, but someone could still access. Could they access?
Oh yeah. In principle, yes. Somebody could use some of the unexported accessors from my library, dig into the actual internal tree objects, and modify them in place if they really wanted to. But the thing is, the same thing is true in Clojure.
Okay.
So
Got
like,
all right.
If someone's doing that, they're being really dumb.
They're violating essentially the API anyway, because you're
exactly.
going.
They're violating the contract of my API.
Yeah.
Okay, so the way that this works, right, is every transient tree has this object called its transient box. Right?
Okay, and what does that represent?
It's a pointer to the current thread.
Okay.
Represented as an object. So really, every tree has a double indirected pointer to the current thread. Every transient tree.
Okay.
Right? That's what the box is. The box is the pointer, and then the tree has a pointer to the box. Some of the nodes in the tree, every node also has a pointer to one of these boxes. Right? And the idea is that if a particular node has the same box as the box of the current transient tree, that node is mutable.
Okay.
Right? And the other idea is that whenever you hit one of the user-facing operations that does something mutable, that function is supposed to, I don't remember if I have it in this particular commit of the pushed library, but that function is supposed to check to see if the box of the transient tree you just passed in points at the same thread that you're currently on.
So you're triggering. So if I'm updating a particular node, or even like adding a node into this data structure, you create a transient box, which effectively is a copy of the.
So let's say you have a persistent tree.
All right.
Right, and you want to insert a node into it.
Okay.
So the first thing you do is you get a transient view of that tree.
Right.
Okay. Which is basically, it replaces the wrapper. Right, because basically each of my trees has this little wrapper data structure, which is the tree itself, and that points at the root node, right?
Okay.
And so it replaces the wrapper from a persistent tree to a transient tree, but it doesn't actually do anything to the nodes. It just keeps the root pointer for the nodes. But at that moment, it allocates a new transient box for that transient tree.
Okay.
Right? And then now that you have this transient tree, you can pass it to one of the functions that does some mutating operation. And the guarantee is that as it's doing this mutating operation on the tree, any nodes it finds which don't have the same transient box as the current transient trees box will get copied.
Okay.
But then if it comes across a node which has already been copied, i.e. it has the same box as the current transient trees box, it can modify it in place.
But how would you know that? Like, why would you have? And that's where my confusion comes in. Why would you have two transient trees with the same transient?
Because so your operation is probably only going to affect a subset of the nodes in the tree.
Right.
And then you're going to make that whole tree persistent. And
so you're making the subtrees all members of the same transient box. You're saying the subtree with its children.
The subtrees that get modified will share the new transient box, but the nodes that haven't been modified will still point at their previous transient box.
Got it. All right. Okay.
Right? Yeah. And so the reason for this is for batching, right? What this does is it lets you do like 5 inserts to the same subtree and not have to copy the parent again.
Yeah, that reduces a lot of copying. Okay.
If you know that you have to insert like 100 things all at once, you make one transient, you do 100 insertions, and then you make a persistent out of that. Yeah. And if you're lucky, that'll save you a lot of copies of intermediate paths.
Yeah, got it. Okay.
So what get node there does is it either makes a new node or it returns the existing node.
Yeah, it either. Okay, I'm with you.
Yep.
All right.
So if the node is null, so basically that function there, you can give it nil and it'll just always make a new node for you. Alternately, if you give it a node that has the same box as your tree, right, then it will just return that node. Otherwise, it makes a copy of that node and sets the transient box on that.
But I noticed that does copy WB node or do this for you then?
It would keep the previous transient box from the old node, so you just have to update that.
Got it. Okay.
And lret there is this really neat function from Serapium that returns the last thing in your let.
Okay.
So that way I can modify that object and then return it.
Cool.
Without having to explicitly add the extra return node at the end of the block.
So, question: like, say you were to modify multiple nodes, does it take like the optimal branching path over the tree, or does it start over for each node?
It starts over for each node.
Okay, that could be an optimization for the future.
Well, that would require. I don't know if there's a way for me to do that and still maintain the join-based semantics.
Okay.
But also, that would require I add operations that are much more high level than I really want to do. Like, I really want the API, just because it would get to be way more of a headache, I really want the API to focus on individual insertions.
Fair enough.
I think this is convincing me more and more that I need to implement. There's a functional data structure that I saw that from Clojure as well. On tries that actually implement tries.
Oh yeah. Persistent hash array mapped tries.
Yeah, it was.
I'm actually working on that right now.
It's that's
the next one that I'm going to be adding to the library.
It's basically an extension to ideal hash trees, which I have to read the original paper to really implement. It's called, but it uses a bitmap vector actually to determine how to do updates. Let me pull that off. I'll tell you the name.
It's curious that you guys call them tries rather than trees, because
they're tries.
Spelled TRIE.
The inventor called them trees, even though they're spelled different, because it's supposed to be named after the word retrieval.
Yes, I know, but the fact that there are trees, which are TREES,
it's confusing though.
Yeah, I know.
I mean,
just saying that's not how the inventor intended it to be said.
I mean, you can't go and rename something. Yeah, it's called a bitmap. It's a bitmapped vector trie.
Hash array mapped trie, yes.
It's the same thing, I guess.
More or less, yeah.
Yeah, and it's basically an extension of the Bagwell hash tree implementation. So I need to first read the Bagwell hash tree implementation and then try and see how this works. But I didn't know that you were working on this too as well. That's pretty cool.
As I said, I'm planning to implement all of the trees involved in Clojure's persistent collections.
Very, very nice. That's going to be
Given
really,
time.
really helpful.
I started implementing splay trees, and the algorithm I'm following actually makes use of join and split.
Yeah.
It might be kind of similar to what you're doing.
So, this size thing I noticed, though, I have a question on, which is I understand the weight and the balance thing, but what is
Oh, the size of a tree. The weight is 1 plus the size.
1 plus the size? Okay,
Yeah.
but
That's just how weight balanced trees are defined.
what is this condition for though? This heavierness, like figuring out which of is this also part of the rebalance? Because I don't see it being used. In the
Yeah.
balance.
Scroll down, 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 down. There. That's where heavy's used. That's to decide. So if the left tree is heavier than the right, we scan for a subtree of the left, which is balanced with the right. If the right tree is heavier than the left, we scan down the right tree for a subtree, which is balanced with the left tree.
Okay, so this is what's helping your balance.
It's minimizing rebalances.
Okay.
So, which type of balanced binary search tree is this?
Weight balanced.
So, I mean, I know there's different types of weight balanced as far as like.
This is it's not beta balanced before you.
Like you can have a weight balanced red black tree.
Yeah, this is purely weight balanced.
Huh.
AVLs use some sort of weight balancing, don't they? I thought, like they figure out the height of the tree to determine what they do.
So you can have a tree which is quote unquote weight balanced in the sense that the tree keeps the balance of the two subtrees just because of its other whatever rebalancing algorithm it uses happens to maintain a balance of the weight between subtrees. But this is actually a tree which is weight balanced. Weight is used for the balancing algorithm. It's actually tracking the weight, and it's using that to decide when to rebalance. It's not that whatever rebalancing algorithm it's using happens to maintain the balance of the weight.
Does it do any rotations?
Yeah.
I think rotate right and rotate left is here.
Like I'm curious about this weight balance tree now because like what's the complexity? Like how many rotations are required? Like red black requires 2. AVL requires a logarithmic number based on the.
I think it's log n, but I'm not certain. I'd have to check.
So
it's actually harder. It's actually a lot harder to analyze the exact complexity on a weight balanced tree like this because it's not as concrete exactly how it's maintaining the balance as AVL or red black are. But I've read a couple papers that have posited that it ends up being, I'm pretty sure I know it has to be bounded by log n, otherwise you'd be violating the complexity requirements of the tree itself. But I don't remember if it's log n or if it's tighter than that offhand.
Okay.
But yeah, well, so the individual call to join here is only going to cause a single, or it's going to cause at most 2 rotations, but an insert involves a log n number of calls to join. That's the idea anyway.
Okay.
You said an insert requires a log n number of calls, but what's the other thing you said?
An individual call to join will involve at most 2 rotations.
Okay. Got it.
It could also require no rotations, depending on exactly what's happened, right? And so I know that the versions of this, like the version of join that maintains red black and the version of join for AVL, they satisfy the extra requirements on AVL, right? Despite the fact that the system will do a log n number of calls to join, only 2 total rotations will occur on an AVL tree, on a red black tree, right? Just because all the other calls to join will effectively just be no ops because they won't require any rebalancing at all.
Interesting.
So
Right.
do you provide the weight to the user of your trees for like implementing something like an order statistic tree, like defining?
Not. I don't have it exposed at the moment, but that wouldn't be hard. I don't have that exposed at the moment, though. No. Actually, the tree itself, the top level tree object is agnostic to the balancing algorithm used.
Alright.
That's why the tree has a reference to the join function for its nodes.
Right. Okay.
Right. The way that I wrote this, if you scroll up to the top, yeah, is that the tree structures, right? They're totally agnostic to the balancing algorithm. And you just have to construct the tree such that it has a pointer to the proper joiner and the pointer to the proper. So like transient 4, right? So you can't even do modification to the tree unless you like dig into the internals. If you only have the persistent tree, you just have the transient 4 function. And the transient 4 function takes the persistent tree and it gives you a transient which shares the nodes of that persistent. Right. But when it gives you that transient, its job is to allocate the box and give you access to the functions that let you do joins and also let you turn your final transient tree back into a persistent tree.
This is more of a basic question, but I may as well ask this since I'm not familiar with this data structure. But this is more like a Lisp question. Why the use of def struct versus just using classes?
Performance.
Okay.
I know performance is a silly reason to bother with this, but also since these data structures don't change very much, once I had the library ironed out, there really wasn't much point not using structs. Like this is sort of the endless debate, right? If you're worried about your API, like if you're developing your API, structs are a royal pain because anytime you have to modify them, you basically have to restart your image, right? But the other side of it is that, like, I've actually written this API before. This isn't my first time doing this. It was years ago, though, and I don't have that code anymore. At least I don't think I do. And so I basically knew what I was going to be doing when I went into it. And so, like, there was maybe 2 or 3 times I had to change the structure of my struct right to the very, very beginning. And then after that, I was kind of good.
Got it. Okay.
And so since I knew the API that I was going for and I thought ahead of it and I'd done this before, I knew how to set up my struct so I wouldn't have to worry about that. The other side of it is, right, that I'm emulating some of the behavior that you would otherwise get through class using generics by storing functions in my struct.
Right. I noticed that too. That was the other question I had. I was like, you seem to be using the struct to construct the objects with the method calls. So is that also like
it's a performance thing?
Okay, got it.
It's to avoid the overhead of a generic function call.
Got it. Cool.
I mean, honestly, as Michael said, it probably isn't going to be a big deal. Like, really?
Like, you won't know until like.
But, you know.
Yeah.
I knew how to set
when
it up.
When I start writing anything, whether it's a data structure or not, I always start in class. You know, with generic dispatch and everything. And depending on the usage of my data structure, if I need it to be fast, then I'll make it a struct. And if I need to add type declarations, then I'll add type declarations. But I always start with class. No type declarations, no actual functions. They're all generic. You know, class slats are generic. That's how they work. It really doesn't matter usually.
Unless for most cases, you're not going to
particular application.
For most cases, you're not going to need to worry about that,
especially for a tree.
Yeah. The reason why I was a little more concerned for this was just that because this is a persistent tree and it has to do a lot more operations and copying and such, I was a little bit more concerned about performance, trying to sort of eke out what I can, despite I know this being a functional style. So, you know, But at the same time, like if I was going into this blind, I totally would have gone through it with class. I would have set it up. That was actually what I did the first time. The first time I did this, like a few years ago, I did it using class. I set it up using generics, and it worked. It was fine. It had good enough performance. It seemed to do the job. But you know, since I kind of knew what I was going for this time, I figured I might as well just, you know, make structs out of everything.
I mean, it makes sense. I just thought I get a sense of your, you know, as to why the design approach was that way. Just because I tend to pick class whenever I get a chance, before switching back to structs, just because of my insanity, just to see how it would work. But I didn't know if there was a different reason for doing that other than just performance. So. Okay.
Yeah, and that's exactly like my library that I showed you earlier uses class, but for my particular use case, which is inside my game engine, I needed an AVL tree that was extremely fast. So I basically just ripped it out of my library and structified everything. So now it exists inside my game engine as, you know, as its own file rather than in the library because I needed it to be structs. I'm using class because I'm making heavy use of generic functions to specialize on different subtypes. Like I have a pretty deep class hierarchy. Like red black are based off of regular binary search trees, and AVLs are based off of red black. So that's primarily why I used class in my library, because I wanted to have a concrete class hierarchy rather than including structs like Elijah is doing right here.
Yep.
Makes sense.
Because I'm using a lot of generic functions to specialize on different classes.
Yeah, if you scroll a little ways down in here, you'll see that I actually have an unbalanced tree implementation as well.
You do?
Yep.
There
it's
it
right
is.
There. Yeah. Yeah, if you scroll up just a little bit, you'll find the unbalanced join function.
There it is.
It's really dumb. So one of the things about the way that I implemented this is the last argument is an optional old node. And what that is it's just some node that the caller of join is going to throw away if you don't use it. Right? It's purely an optimization.
Is that but part of it is also do you put do you have some atomicity guarantees when you're trying to update a node inside?
Nope.
Okay, so there aren't. Okay.
Nope,
Right.
That's the reason why the transient box holds a pointer to the current thread.
Got it. Okay.
Because the high-level user-facing API will refuse to let you do anything if you're on a different thread than the one where the transient was created.
Okay. Cool.
Because the idea
a little simpler then.
Oh yeah, and that's a thing I stole from Clojure. This whole thing is stolen shamelessly from Clojure. And the entire point of that is that if you want to be sharing on multiple threads, you really, you ought to be making a persistent out of that and handing the persistent off to the other thread.
Yeah.
If you want to see something scary, I just posted a gist to self-contained AVL tree.
Let's see this.
Yeah, that code is pretty scary. I wouldn't go analyzing it.
Yeah. I wouldn't know scary common Lisp code just yet, just because I haven't read enough scary common Lisp code.
Honestly, my code's pretty scary too. Like, I'm sure Michael wasn't, was.
Oh, wait till you get down that file. Wait till you get down that file to like rotations and everything.
Oh yeah, actually, I'm really proud of my rotation function.
The one that for the BSC.
Oh yeah. It's in weight balance join. You passed it.
Oh, I did.
It's a labels function.
Oh, there it is. Rotate left. Rotate left. Right. Okay.
So so, so get node just freshens up that node to make sure it's a node that I'm allowed to mutate. So get node just freshens up that node to make sure it's a node that I'm allowed to mutate. So get node just freshens up that node to make sure it's a node that I'm allowed to mutate. So get node just freshens up that node to make sure it's a node that I'm allowed to mutate. So get node just freshens up that node to make sure it's a node that I'm allowed to mutate. So get node just freshens up that node to make sure it's a node that I'm allowed to mutate. So get node just freshens up that node to make sure it's a node that I'm allowed to mutate. So get node just freshens up that node to make sure it's a node that I'm allowed to mutate. So get node just freshens up that node to make sure it's a node that I'm allowed to mutate. So get node just freshens up that node to make sure it's a node that I'm allowed to mutate. So get node just freshens up that node to make sure it's a node that I'm allowed to mutate. So get node just freshens up that node to make sure it's a node that I'm allowed to mutate. So get node just freshens up that node to make sure it's a node that I'm allowed to mutate. So get node just Right, because it copies it if needed, makes a node if there isn't a node there, etc., etc. Right, and do you know what callf does?
I've never used callf from Serapium.
So it takes a function and a place and a bunch of extra arguments. It gets the value at that place, calls the function with the value and the extra arguments, and then assigns the result back to that place.
So it's the same. It's the equivalent of a fun call to a setf.
Yes.
Okay.
Yeah.
Okay.
It's fun call plus setf. Except it only evaluates the place once.
Nice. Does Serapium provide an if-let and
No, that's Alexandria.
Yeah, Alexandria has that.
Serapium brings in Alexandria, I believe.
So
I
don't
always
necessarily
refer to
need
Alexandria stuff using A anyway.
Got it. All right.
But yeah, no, Alexandria provides if-let.
Okay.
But yeah, so my rotate left function there. Yeah, get the node, get a node, make sure that the node and its right subnode are okay, and then rotate F.
That's it. That's pretty neat, man.
Yeah, you move the right child to the root, you move the root to the left of the right child, and you move the left of the right child to the right child.
Nice. You didn't do that. That's the simplest rotate function I've ever seen, man.
And then rotate right.
Yeah, you want to see what's not simple? Scroll down to my insert function.
Oh yeah.
Your make insert.
Line 200 something.
Insert rebalance.
Insert, which calls insert rebalance. Look at both of those functions in combination.
No, stop this right now. This hurts.
Yeah, look at that.
Oh my god!
Don't study that.
That is insane.
And that's only half of it. Insert calls that at the end because it has to perform that after it does a regular insert.
Oh, look, on the bright side, I will say that I'm happy that you're using loop.
Happy that I'm using what?
You're using loop instead of writing a lot of craziness in because you could write this completely in a pure functional manner and write it as recursion. But
oh yeah, you should see my insert for that. Yes,
you could. I in a lot of places I chose iteration over recursion because I noticed that I was blowing my stack with huge trees.
So for a persistent tree, I have to use recursion because I need to construct the path back again.
Right, that's right. You're using you're essentially using depth first search to figure out the tree that you need to go and update, right? And then
basically, well, I mean, you can look at it if you head back over to mine, and scroll up to my generic insert routine.
This one.
Yes, insert bang. Yeah. Look, I did remember to introduce the thread check.
Go back to scheme.
Ha. Yeah, so I get the comparison function from my tree and the joiner from the tree, right? And then I have a little recursive function there, and I just say, well,
I've never seen this many fun calls in a single function before.
So,
oh yeah, well, because I have these functions from. I mean, I could use Serapium to what is it? Serap has a macro which lets you bind a bunch of f-lets from a bunch of expressions that return functions. I probably could use that and it would really clean it up. I might actually make that change this afternoon. I just realized that would make that a lot
I'm curious
cleaner.
if your code is subjected to the same types of problems that my original version had, since it's using recursion. I was blowing my stack like crazy for somewhat large trees.
I haven't noticed that, but I mean, I guess it depends how you define somewhat large.
I noticed that your use of check type here on T-tree.
Yep. Because
What
that's
is-
not a performance thing.
I learned something
That's-
new when I wrote my
that's
tree
an assertion.
algorithm in regard to check type. Did you know that
Yeah.
check type is side effecting?
Oh yeah, it's restartable.
Yeah, my my F-type proclamation was freaking out because it couldn't determine the type since it kept changing.
Oh yeah, because check type is side affecting because it's
it keeps changing. Yeah.
Nice.
But yeah, so what I do there, right? I have the node, and if I actually have the node, I get the key of the node, and then I check to see if the key that I'm looking for is less than that key. In which case, I call the joiner on the tree, and then you'll notice I recur on the left subtree, right?
Yes, I saw
Right.
that.
So I recur on the left subtree, and then I rejoin the result of inserting into the left subtree with this key, this value, and the right subtree of this node.
But you would have to do that anyway because of the fact that once you insert into the function into the tree, right? The joiner is what's doing your checks for rebalancing, isn't it? I mean, for
Correct.
balancing the tree. Okay.
Yes, exactly. Then that's the point.
Yeah.
Do you have walking implemented yet?
I don't, but that shouldn't be hard.
There's 4 different walks.
Yeah, I know. I'm aware. I'm probably going to.
In order, you probably definitely do not want to use recursion.
I was actually
make your own stack and pop things off.
I was actually planning on using I was planning on using CLCont to implement the walks.
Okay.
And the reason being that reifies the stack for me, implicitly, and it also means that I can make sure that if the lambda that gets passed into me is a lambda that can take a continuation, because CLCont does that.
Hold on. Did you say CLCont or CLConj?
Cont.
Oh,
CONT.
Okay, so that's the continuation. Okay, got it. All right. Got it. All right. I was just like...
So CLCont has a fun call non-deterministic.
Okay.
It lets you have a lambda which can take a continuation. Right?
I'm trying to pull up the API.
That's the one. Yep.
Okay, that's the one.
So the reason why I want to implement my walk functions using CLCont is A, it gets me the reified stack implicitly, but B, if the it means that the walk function that gets passed in, because I'm going to implement it basically, it just takes a function that gets called on each element in order, right? But because it gets called with an explicit continuation, that lambda can capture that continuation and then perform an early return.
Oh.
And that way, a user can still use my walk function as if it were yielding.
My walk function is really simple.
Yeah, I know. I'm being silly when I talk about doing stuff like that, but I have dreams.
I have dreams. Excellent. Oh, jeez.
But yeah. So my point is just that it goes through and it does the operation recursively, and then on the walk back up the tree, the way it reconstructs the tree that's going back up is it calls the joiner again at each level, and that makes sure that everything rebalances properly.
That makes sense.
Right, and then you'll notice that the thing that gets passed as the last argument to the joiner is the current node. And the reason for that is that, otherwise I'm just going to discard that node, and if it turns out that I'm allowed to mutate that node, the joiner will know that and it'll reuse it.
Huh. Okay, so you have your base case and the joiner will recognize that.
Well, that's what get node is for. The whole point of the last argument to node getting the old node, or the last argument to join getting the old node, and then get node checks to see if the node you passed it is a node you're allowed to mutate, right? That it makes sure that it can reuse that node, right? So the idea is that my joiner, despite being purely functional, that's the way that it avoids always allocating a new node as it's going along. Because functions that use it can basically pass it in a node that they know will otherwise be going to waste.
Out
So
of
I have a really
curiosity,
dumb question.
what's the largest data set have you tried using to test your implementation so far?
I forget what tests I ran. It was like a week or two ago. I've gotten so deep into persistent, hash array match tries that I've kind of forgotten. It was a couple thousand nodes, I think.
This is convincing me. I may want to revisit and actually read and implement Okasaki's persistent data structures along with Clojure's data structures just to
So I
see.
have a dumb question for you, Chase.
Sure.
I mean, this is probably really dumb, but I've only used persistent data structures in Clojure. What would using your library in Common Lisp provide, like as far as like all the mutability that occurs elsewhere? Like, what's a good use case for your library?
So this library on its own, there really isn't a good one on out of the box, right? But the idea, my sort of long-term plan with this is that I'm going to, once I finish implementing these trees, I'm actually going to write another library which actually implements Clojure's collections API. And probably also, if I can, integrates with Zulu's sequences API, his CL enumerables.
Oh, right. Yep.
And so I feel like the combination of like my collections API, mimicking the Clojure full collections API, and his sequences API would produce something actually quite nice and useful.
Okay. Cool.
But just the trees on its own, yeah, no, that like you need a lot more stuff. Like a lot more utilities atop that to actually be a good thing. This is
enumerable API, the .NET one that he wrote?
The one that he based off .NET, yeah. Although he's actually planning to, and kind of has already, started to transition over to using something closer to Clojure's sequences.
Okay.
By the way, line 118 there, that should be a regular let.
It can be a regular let.
Yep.
It could be a regular let, yes.
It doesn't need to be.
But yeah. Yes, you're right. I probably should make that a let. That was the result of a refactor that I didn't quite complete. Actually, scroll up a little.
Yeah, sure.
There's some neat stuff here. Is how I've got these utilities here implemented. There's split. So split basically takes
all your lets are let stars, even single bindings.
Yeah, as I said, what you're seeing here is the result of multiple refactorings, and I never bothered to go back through and remove all the let stars. There were reasons for that before. To be clear, those needed to be let stars like 1 or 2 refactorings ago. So what split does is it breaks a tree into based on a key. It breaks a tree into the left subtree, the right subtree, and a node that has that key. And so basically, if you combine split and join, that effectively is the splay operation in a splay tree. Except in my case, it would rebalance as well afterward. Depending on the implementation, basically, in my system, you could have a splay tree if you use the unbalanced tree implementation I have, and then you used the split and the join functions every time you did a lookup, right? Because that's what splay trees do. They basically move that node to the root,
right?
And so the idea here is that split does whatever it needs in order to break your tree up at that key, right? Mm-hmm. And so yeah, it's kind of neat. So I don't know. I like these functions. They're kind of fun. Split last is also neat. It extracts the rightmost element of the tree. So it returns the it returns a tree and an element, and a node. It returns a tree and a node, rather, such that that node is the rightmost node of the original tree. And the new tree that you get back has had that node removed.
Would that just be the max function? Or, I mean, what do you call it?
It's effective. Yeah, it extracts the max, but it also gives you back the tree with that max removed.
Okay, so yeah.
It splits out the max node.
You said split tree on the split node, and you're returning.
So no. So multiple value bind. I'm getting the result of splitting the right subtree of this tree.
Got it. No, I'm just going through it. So your function, your base case is if this is null, you're returning the left node.
Right. So the idea is that if I hit if I hit a node with no right subtree, that's the rightmost node in the tree.
That's right. Okay.
In which case, I can just return its left subtree as the result, right?
Right.
That, and then as I go back up the tree, I then have to take the subtree, the result of splitting out the rightmost node from the right subtree, and join that back in with the tree that I have, right? So that's why I'm joining the left subtree of whatever, so I've just split out the right subtree, right? And now I have the current tree's left subtree and current key value pair. And now I need to join back together that with the result of splitting out the right subtree. Does that make sense?
Yeah, that makes sense. I'm actually drawing it out on paper because it's very hard when you're talking about tree walking.
Here, give me just a moment. I'll share my screen, and then I can use my mouse to point at stuff.
All right.
GitHub/Jace97/
Well, the line is setting up for folks who are actually on the call. Do you guys have any questions? Judd, I see you there, silent, just listening away, as well as Michael Gargano. All right.
There it is. Share. Cool.
Boom.
I can share tabs. I have no clue what this looks like for you guys, but
it looks kind of weird, man.
I'm sharing a tab.
Yeah, I know. I'm just saying that it looks very, very interesting in Jitsy's interface.
Yes, it does.
Huh.
It's all letterboxed.
Oh yeah, I see that. That's neat. But yeah. I split the right subtree, right, and that gets me back whatever else was in the right subtree that wasn't the rightmost node in that subtree, and the rightmost node in that subtree.
Right.
Right. And then what I have to do is, so my joiner here takes a left tree, a key value, and a right tree. Right. And so I'm taking what was left over from splitting out the right subtree, and I'm joining that as the right subtree again back up together with, the tree that I'm currently at. So I extract the left tree of this current node. I extract the left tree of this node, its key value pair, and then I say, well, take whatever was left over from splitting out the right subtree and join that back in as the new right tree.
Oh, I see what you did there. Okay.
Yeah, my brain was like Stack Overflowing, trying to work through that recursion until you explained it.
and so this gets me back together, the new tree at this level, but with that node split out.
Okay.
I'm joining back in whatever was left over from the recursion with whatever I have at my current level.
Got it.
Right?
That's what missing. So basically, you're replacing the right subtree with the split tree.
Yeah, with whatever was left over from splitting the right subtree.
Yeah.
Yep. I'm replacing the right subtree with whatever was left over from splitting out on the right subtree.
And how is this? What are you?
I was going to ask, what is join 2?
Yeah. So join 2 is join where I don't have the middle node. I don't have the middle key value pair. Right? I just have a left subtree and a right subtree, but I don't have the key value pair that goes in the middle. Right? And the way that works is I split out the rightmost node from the left subtree, and then I use,
use that as the key and the value. Okay.
Yeah, I use whatever was left over from splitting the left subtree as my new left subtree, and then I take the key value of that node that I split out as my current key value, and then I just take whatever I got passed in for the right subtree, and I join that together.
Interesting.
Yep. And since I know that rightmost node will go to waste if I don't use it, I pass that in as the old node. So that's used in delete. Because the idea with delete, right, is that like insert, the recursive cases are actually the same, right? The recursive cases for delete are exactly the same. If my current key is less than the key of the current node, right, I do a recursive call on the left subtree, and then I join that back up. If the key is greater than that, I do a recursive call on the right subtree, and then I join that back up. But when I get to my base case, I actually want to get rid of the current node. So I do a join 2 on that node's left and right subtrees.
And that calls split last to do the actual removal.
So that basically joins together the left and right subtrees without their original parent.
Yeah.
And then I return that
as
the new either left or right subtree. And so that lets me do all of this. This is totally generic to whatever balancing algorithm I'm using. All of these are totally generic to my balancing algorithm.
Cool.
Yep.
Really cool.
Yeah, and the really crazy thing is that there's a paper that proves that there are ways to write a join function for weight balancing, for red, black, and for AVL, such that when you write your insert and your delete and your union and intersect and I think they also did subtract, I think set difference, they're all work efficient, exactly the way that you would expect them to be if you had a mutable tree with that balancing algorithm.
Cool.
Mm-hmm. Can you see my mouse, by the way?
Yes.
Okay, that's neat. It actually still shows the mouse. Huh.
It's everything's letterbox, but it's really, really nice. It's very focused.
I mean, it's literally the tab. Like I can see, it's for me, the tab's got a little nice border on it.
Yeah.
And it's sharing this tab. But yeah. Anyway, so yeah, I'm rather proud that I got this all working.
You should tell us if you have any tests or something.
Yeah, this looks really, really cool. I probably gotta keep twisting your arm so it doesn't become one of your unmaintained, unfinished.
Yeah, you probably need
because I want to see this finished. I want to see it finished, man.
You ought to.
So
you do actually need to bother me. So I'm halfway done implementing persistent hash array mapped trees, and I have all the stuff that I need worked out for. I actually got a mutable hash array map tree implementation working, like with proper bit mapping and all of that nice stuff, all the log count stuff and all of that. I have that. It's just I need to turn that into a version that uses that's persistent but allows for transients, and that's been a headache, and I've been putting it off for almost a week now.
There's a bunch of rules there that you have to kind of follow, right, for the transients, but I think they follow along the same lines that you've implemented this.
Oh yeah, it's actually easier than it was for this one because I don't have to deal with making it generic to the balancing algorithm.
Right. Absolutely.
And also, eventually, I need to implement the other balancing algorithms someday.
Did you read that paper that I sent to you about the new weight balanced tree?
Yeah, no, I still have. I've read.
I'm wondering
parts
if that can be done with joins.
Maybe. Give me just a second. So yeah, there's that one. Let's see where's the citation for it that I'm looking for. It's a particular paper that I've been basing a lot of this on. That Yeah, I think it's this one. Parallel ordered sets using join. Yes. Let me change which tab I'm sharing. Chromium tab. Parallel. Yeah. No.
Wrong tab.
Yeah, that wasn't what I wanted at all. This one. Yes.
Boom.
Parallel ordered sets using join.
Could you, increase that? Okay, cool.
Yeah. So this is the paper that documents how you implement each of these operations using just join. Right. They actually did insert and delete even more simply than what I did. Right. They do it by splitting on the key and then joining again, which is certainly an option. But my insert is just it doesn't require a split. Instead, basically the way that I wrote it, it requires a log n number of joins, but it avoids needing a split. And the split would require a lot more rebalancing, I think. It probably works out in the end. It probably works out either way. But like because of the way the split works, one of these two subtrees will need to get like actually broken out, and it'll need to be balanced on its own. Right? Because the way that this works, right, is you're going to have. I wish I could draw on my screen.
What is expose in your library? I haven't seen that one.
Which
So
one's
split
exposed?
Split last and intersect have it, and union have it.
Yeah.
Expose is a utility.
Split has it too. Yeah.
Expose is their destructuring, basically.
Okay.
Yeah, expose is just how they notate getting a tuple that is the left key value and right of that node.
Oh, okay. So expose that's multiple. Okay, got it. Okay.
Yeah.
Multiple value bind. All right.
Well, yeah.
It's
Well,
right
just
there at the bottom of your screen, actually.
Yep. Yeah. Expose returns the left tree key and right tree of a node. I just inlined all the actual array accessors anywhere I needed them.
Got it.
Or
Is
the struct
this paper online?
Yeah. I can post a link to it.
Yeah.
This is, it is now in chat.
Sweet.
But yeah, so here are the algorithms. So I still need to implement these union, intersect, and difference, but they aren't hard, as you can see, and totally generic, and this probably, this makes like what the split last is a bit cleaner with, you're reading it like this, if the right subtree is a leaf, then just return left and key, and otherwise split last on the right subtree, and actually,
so this paper explains how to do this.
So
for red, black, and AVL too.
Here we are. Here's the AVL join algorithm right there.
Wow, now I want to rewrite mine.
Well, so keep in mind this is like 4 persistent trees, right? This is this is the way of doing it that makes sense most for persistent trees as opposed to mutating ones. That's kind of why I was doing it, because I knew that I needed to be persistent. But yeah, so I also found that trying to figure out exactly like what their notation was for AVL and red black has been a bit of a headache. I've been kind of following it, but it's still requiring a bit of understanding. Whereas the weight balance one I've been able to follow. They talk about a whole lot of stuff on here, and eventually they actually talk about basically how they define a property of each type of balancing algorithm, which is the what is it? R, I think, is the property. Yeah. They define this. They talk about this R property, the rank of the tree, and it's related in each of them to the height, effectively. But it's defined slightly differently for each balancing scheme. And the reason for that is that it's basically they write all of their proofs that these implementations work based on the rank. Based on how the rank changes as you do join operations. And then they also prove that assuming the rank changes using proper ways with these join algorithms, all of these operations are properly work efficient. Based on, join properly manipulating the ranks. So that's why, I know that it works, basically. Yeah, so for 2 alpha weight balance trees. Oh, yeah, and this is where I got the 0.29 from, by the way.
Yeah, we should. It's not being nitpicky here, because I understand getting it working first, but you may want to like label that just so that you don't forget what its intent is. I've taken out constants in the past from code that I realized, oh, there was a reason that was there.
Fair enough. Yeah, I probably should label it. But yeah, the weight balance join algorithm works correctly. It runs with log of, weight of TL over weight of TR work and returns a tree satisfying the alpha weight balance invariant with rank at most, blah, blah, blah. And then they show that proof in the appendix.
Nikes, they implemented treats with this too?
Oh, yeah. Yeah, they also have a treep one.
Dang, man. All right.
Yeah.
That's pretty cool.
Yep.
So with these implementations, you've effectively implemented 4 or 5 data structures.
Right, in principle. I only need to implement the actual join operation. I've only implemented join for weight balanced, but I could implement the other join operations, and then the rest of my whole thing would just work. Yeah.
So that's
pretty cool.
So this low-level library can really help your collections library.
Yes, that's the point.
Yeah.
Yes, the entire idea. Yes. The entire idea is that I wanted to write a very generic trees library, including all the different kinds of trees I needed for the collections enclosure, and then my collections library would wrap them up in nice, pretty interfaces.
Very, very nice. I'm very excited about this.
Yeah, the collections library is going to use a lot more class stuff, right?
Are splay one of those trees that you need?
No, I don't think so anyway. Splays aren't persistent. Because you have to modify the structure of the tree when you're doing lookups.
Yep.
And so you can't really implement splays in a functional way, per se. Like you could in principle have a lookup operation that returns as like a secondary value a new tree such that that node has been moved to the root, and then have somebody like do all the work of threading that around. You'd probably end up using a monad for that effectively. But like on their own, splay trees are like not really built for persistent work.
According to Wikipedia, there's a way of implementing them with persistence, but I don't know if I can trust this or not. I'm pretty sure it would work. It's pretty accurate, but who knows?
I mean, like, I wouldn't be surprised if there exists a way to implement splay trees persistently. The question is more, is there a way of implementing splay trees persistently that satisfies also my requirements about, thread safety? Because, I'm pretty sure that there's a way of implementing splay trees persistently such that the internal mutations preserve the ability to look at old views of the tree, and stuff like that, which is technically, the definition of what it means to have a persistent view, right? As long as you can still look at old versions and they still work, you've got a persistent data structure. But that doesn't necessarily mean that it's a thread-safe persistent data structure, because that mutation operation might not be thread-safe anyway.
You're right. And you're right. This is the disadvantage. It goes on to talk about that they're changed even when they're accessed in read-only manner, which makes them particularly makes it harder to use split trees in multi-threaded and concurrent environments. So,
Right.
So I see why you say that it's going to be difficult for them to be used in a pure FP manner.
Right. Yeah, because it's like they may talk about it being a persistent data structure, but I don't think it's a pure FP data structure. I don't think it's like mutation free.
Yeah, it is not mutation free. You're right.
Because the entire point is that lookups restructure the tree.
Right. Right.
And if lookups restructure the tree, then, well, you either need your lookup function to return a restructured tree, or you've got mutations going on.
Right.
And
I didn't realize splay trees you can implement garbage collectors with splay trees, but that makes sense now, thinking about it a bit more.
Huh. Yeah, I suppose that makes sense.
Yeah.
But yeah, so I'm really pleased with the work that I've done so far on this, and I'm gonna implement persistent hash array mapped trees next. I'm most of the way through, as I said, and then I'm going to implement the tree that's behind Clojure's persistent vector, because Clojure's persistent vector also uses a tree. Yeah, it's a persistent data structure. You basically can't avoid a tree.
You can't avoid it. Yeah, that's right.
Yeah, right. It's a persistent data structure. If you want it to be any kind of efficient, there's going to be a tree in there somewhere.
Somewhere in there. You're right.
Yeah. Have you guys ever seen Clojure's persistent vectors?
No,
like the internals of it? It's actually really neat. The way that it works is it's made up of a bunch of vectors of size 32. And you only store values in the leaves. And every time the vector gets too large, you basically just add another level on top, right? So at first you just have the single vector of size 32, and then you get to more than 32 elements, you basically make a parent 32 element vector that points at that old one, and then you make another 32 element vector, and you have the second element of the parent one point at that.
Right. So that's what the bitmap vector tries helps you with, because you can use
vector tries do something very similar. Yes.
Because if you try to get the 14th element, right, what you're actually doing is you're doing a lookup at the top level parent node, right, to figure out where to split in the bit representation, to figure out which cell to actually go in to find the try node that actually is pointing to the collection.
A vector is compact, right? But you're right. The try implementation is very, very similar. Although the bitmapped try can actually still store values at the intermediate nodes.
Oh, I didn't know that.
Right.
Okay.
Yeah. So the persistent vector only stores values at the leaves, and it's compact. You don't have gaps.
Right.
Right. Because it's a vector of length whatever, and you just have values at everything through the whatever.
Right.
Whereas a try or a bitmapped hash try, it's like you would expect it to be sparse. Right? Yeah. If it's not sparse, there's something wrong, or you have an awful lot of stuff in that try, like gigabytes of stuff in the try.
Right.
And so it's slightly different in that sense, but you're right. There's a similar thing going on in the intermediate nodes. But the other bit of trickery that they do in Clojure is they actually so one of your 32 element vectors is always going to be partially filled unless your size is a multiple of 32. Right. That's just sort of the way that it works. And in Clojure, they have this really neat little optimization where the rightmost vector that's partially filled in actually gets pointed at directly by the root instead of being somewhere deep in the tree. And the reason for that is repeated inserts at the very end. Right, so if you're pushing onto the very end of the vector, it only has to copy the root and that one node instead of having to do a copy down to however deep into your vector tree you have.
Interesting.
Yes, it's a sneaky little.
I think this would be a good thing to do to implement as a case study. Like, I should like implement it. We should try and implement one of these things live. It'll be difficult, but it'll be an interesting coding exercise.
Yeah, actually implementing the persistent vector live might not be a bad idea. I'd be up for that.
Yeah. So we're over time.
Yep.
I noticed. We could keep going here, but I'd rather not take up too much of folks' time for this episode. Tune in next week. I will. My
Ram?
hope is my.
Sorry, Ram.
Oh yes, sorry.
Ram. Yeah. Hi. I'm sorry, but before we go, can I just ask one? I didn't want to go off topic.
Sure.
Because we're on a different path, but I just have one quick question that I hope it's quick. Something I don't understand. I don't know. Do you have a Lisp image up? Still running?
Hey, I do have. Yes, I do. Give me a second. Let me pull that up.
Yeah, if you don't mind. I just had. I hope this is something quick, but.
We'll see.
If it starts getting too hairy, we could just cut it short and handle it some other time. I was just curious because this is something I've had trouble understanding. So, let's say that I have a variable in in my program like x. So if I do like at the top level, if I do a set f x without doing a def param or anything, and I give it some value 7 or 5, that's fine. And then, I can refer to x now, and I'll get back 5. And if I use that in my program, I'll get back 5. But now, if I do a def parameter on that same value, and I set that to like 7, let's say, now I'll get back 7 for x. But then I think if you do symbol value on x, you get back the 5 because the x is technically global at the set f value, but not at the def parameter value.
You need to quote that symbol.
Yeah, thank you. That's right.
I don't know, it came back 7. No, because I could have swore that maybe it's when you're using it in a function. That when you do a symbol value, you get back the value of the top level set f before the def parameter.
Let me restart this image and start this again.
I don't know if anybody knows what I'm getting at here.
So if I do set f x5, and then let's say that I do a defun, you're saying, let's call it foo. And I'm guessing you want to use x here. So let's say that
you could return multiple values. You can return x and the symbol value of x.
Values x. Value x. Okay.
All right, and you call foo.
Okay, so now you got 5, 5.
Right, you got 5, 5, and then if you do a def parameter on x and set it to something different,
let's say 7, and then I call foo again.
Yeah, is that still coming? No, that's coming back 7, 7. I could have swore there was a case. Maybe
Are you using Clojure CL or are you using a different Lisp?
No, I was using SBCL, but you know what it was? I think it's okay. I think this is what it was. So if I do a setf x at the top level to some value before x is defined, and then I guess maybe I was using a special variable. When you're in the function and you do a symbol value, right? You're not getting the value of the special variable. You're getting the value of the global.
You do declare.
But there's something funny with def parameter, because if you use def parameter versus defining it with a setf, you don't get the same functionality.
Well, def parameter automatically creates a special.
So are you saying that you did something like this where you declare special x, and then you I think this is the correct syntax. Correct me if I'm wrong, folks. Pretty sure I'm right there though. Yeah, I think that's right. Yeah, okay. So let me see. Actually, let me do this. Let me call this foo2. I'm going to use Y now. That way. Okay. Shift. Let's do set F Y 5. Okay. 2. It's 5.
Okay.
Now let's do
yeah, I'll have to check the version of SBCL I was using, and I mean this was a couple of months ago. It never came up in discussion, but it seemed like symbol value did something very different depending on if you declared something with like a def param or if you just did a top level set F.
There is.
And I was just wondering if there was like any subtle difference between, like when you just do like a set F at the top level without anything else, if there was like any kind of special handling of it by like SBCL that wasn't.
My understanding of set F is it does a lookup, and if the symbol is not there, that is, it's uninterned. What it does is the same process as def var does, in which it interns it, and that creates a new symbol object, and then it then sets the value. It calls the actual set Q to actually set the value on that symbol object. Def parameter essentially is the equivalent of def var plus set F, is my understanding. I don't think the behavior should be identical, unless there might be a path where they used a different function at some point, and now they're both uniform. It might be a different version of SBCL that handled it. But I could be wrong that we might be doing different things in different cases.
Yeah, I should have made a note. I meant to make a note of it, and then I never did. But
not a problem.
I was reading the Elements of AI by Tanemoto, and he was doing. I was following along with some of the stuff in there at one point, and when he was doing symbol value, basically the way that he was doing things, I was getting some really funky like values and stuff, like things I would set things one way and then I'd set them another way, and I was getting like the original value depending on how I accessed the variables.
Mm-hmm.
So I was just wondering if anybody knew of anything like that, if there was any like technical distinction between like what he calls a quote unquote global versus like anything defined with like def parameter or def var.
A def parameter and def var are technically in the global symbol table.
Well, they're special variables.
Yeah, they're
special
dynamic
variables.
What
so they have a
been
stack
happening?
of values.
Sorry,
So
I've been distracted.
no worries. The question is there a distinction between def var declaring a variable using def var and def parameter and just calling set F directly?
Yes, there is. Yes.
Massive difference.
Set F does not declare that variable special.
Technically speaking, set F at the top level, when you haven't declared the variable some other way, isn't even defined behavior.
Yeah, that's what I'm getting at, because it seems like you get some funky behavior depending on how you access it later. So yeah. I didn't know like how SBCL like handled that. Like what happens when you do that? Because
if
the
I
way
remember correct,
Tanemoto does it,
it'll emit a warning saying that it's undefined.
So
right.
Ram, can you restart your image?
Yeah, sure. There's another question that just popped up too now on the YouTube channel.
I have a specific example I want to test real fast.
Okay.
Do set F of X to be like 5.
Okay. Set F5. Okay, got it.
Now, do defun foo. Take some argument I, for example.
Okay.
And then does plus xi.
Okay.
Enter.
Okay.
All right, so that didn't actually do what I thought it did. Look up X right now. Okay, and now call foo. Okay, so right, it's still doing
See, I
a
think that
special
used to do
variable
something
lookup.
different too.
It's still
Yeah,
treated
I
as special.
I think before SBCL declared it as a lexical if you just said it blindly.
Yeah, because it used to handle it
because
differently when you called it.
because SBCL has a notion of a global lexical. Like it actually has a notion of that somewhere in the internals. I don't remember where.
Okay.
But I think just assigning to it blindly like that made a global lexical instead of a global special before.
Gotcha. So that was just like an SBCL specific behavior, basically, because it's undefined in general.
And now I think what happens is SBCL sets the global value of the symbol, but it doesn't declare it special. And the effect of that is that since foo there doesn't have an X to refer to, it assumes that it's some variable that you're going to declare special later, so it still inlines a special variable lookup when it sees that X. And so even though X hasn't been globally proclaimed special, the special variable lookup that gets inlined there, since the compiler doesn't know what variable you're looking for, still looks up the global variable value of X.
Yeah, you know how you might be able to do it? You might be able, if you do a set F at the F, like X on the top level to like 5, and then you have a function that references it, and then you do a def parameter on X to like.
Oh yeah, actually, here's how you can do it. Here's how you can do it.
And then you wrap that. You change the X before the call to foo, because now you're affecting the. I think you're affecting the special parameter. And then if you inside call symbol value, I think it gives you back.
Here's a way you can do it. Here's a way you can do it. I have it. Yeah, so that's fine.
Okay.
That's fine.
Okay, so I'm gonna go ahead and do this, but then
and now define a bar. No, defun bar.
Oh, bar. Okay, got it.
Takes no args. And then does let X be 3. And then calls foo with, 2.
Yeah, exactly.
Enter. Now call bar.
That's 7.
But that's
right.
wrong. That's
because
wrong.
I haven't changed the value of X yet.
But you let bound a variable that should be globally special.
Right. That's correct. Okay. That is wrong.
So since X hasn't been proclaimed special, what bar created was a local variable X, and so it didn't create a dynamic binding. And now, even if you def parameter X to be like 2, like def parameter X is 2, and now call bar again, you'll notice that now that's different, right? Because it did 2 plus 2 is 4.
Right, and that's because of the fact that def parameter x2 has changed.
Now here's the crazy bit. Redefine bar.
Okay.
Enter. Now call bar again.
Oh, crap. That's awesome. Okay.
Because now X is globally proclaimed as special.
Yeah. So
now when you let bind against it, it created a dynamic binding.
Oh, shit. Okay, so...
Yeah, this is confusing as hell.
This is why we earmuff our globals.
Yes.
This, right
here.
is why we earmuff our globals.
So set X creates a symbol object in the global symbol table, but it doesn't
So the reader creates the symbol object.
Right, but it creates it in the global symbol table,
mm-hmm.
but it doesn't turn on the special flag, so it's not treated special.
Correct.
But foo still looks up because we've defined foo.
So since x isn't declared as a variable like at all,
Yeah.
properly, your definition of foo, when it sees x, it goes, well, I don't know what that is. And SBCL tries to be nice when it sees an undefined variable, and it assumes that it's a dynamic variable that you just haven't declared yet.
Right.
And so it assumes that it should do a dynamic variable lookup there. And so it does.
So that's why when I had defined that function and I was calling symbol value inside it, because I didn't redefine the function after I did the def parameter, it was giving me back the value of the
So
globally
symbol
set
value always does a dynamic variable lookup. Symbol value always does a dynamic variable lookup. Even if that variable should be a local variable, symbol value always does a dynamic variable lookup.
Yep. So does just the symbol by itself.
No. If it's a
No?
local variable, it doesn't.
Oh
You
yeah,
can run
yeah. You're right. Okay.
But so like you can get into weird situations. Like here's a fun one, right? Define Baz as symbol value, no args, as symbol value of quote,
X or
spam.
okay.
Okay. Call Baz. Error, as you'd expect, right? And queue out of that, right? And then now you can do let spam be,
whatever.
eggs. Call Baz.
Oh, dang
Still
it.
be an error. Still an error.
Right. Still unbound. Right.
Now, here's the tricky bit. Cue that. Add to your let in the body, declare special spam.
Right. And that will work. Then it will do. Because you now turned on the flag.
Right. Lexical variables cannot cross function boundaries.
Right.
We've locally turned on the flag.
That's right.
Now, here's another way you can do it. Prog v.
Oh boy.
List. Call list. So list, actually list.
Oh, list.
Yeah. And then quote spam. And then close that list. And then another list with the string blah. And call Baz.
Wow.
Prog v is a special form that takes a list of symbols and a list of values at runtime and introduces dynamic bindings.
That's crazy, man. But spam isn't defined, though, right? It's still not defined if I do it at the global level.
Correct. It's not defined globally, correct. But it can still have a dynamic variable stack. It's just unbound globally. And it's not globally proclaimed special.
It's my
special. So the special declaration just affects what a binding to that variable will do. That's all it does. The special proclamation affects two things. It affects what a binding of that variable will do, and it affects what a local reference to that symbol will do. Right? So the special proclamation affects what a binding to that symbol will do, and what a local reference to that symbol will do. So if the special declaration is in effect for a block of code, bindings to that symbol on that code will be dynamic bindings, and references to that symbol in that block of code will be dynamic variable lookups, right? What def parameter does is it globally proclaims that symbol is special. So now every occurrence, every binding, and every reference to that symbol everywhere will use a dynamic variable lookup. That's all the global
in that thread, right?
No. Everywhere.
Everywhere. Same thing with def_var. The only difference is you can
def_var
supply
and
an
def
initial
parameter
value with def parameter.
Yep. Def_var and def parameter globally proclaim that variable is special. Really, proclaim just means globally declare.
Yeah.
So they globally declare, they proclaim that variable is special. And all that does is it makes it so that any future let bindings or local references to that symbol do a dynamic variable lookup. It doesn't necessarily mean that there's a global value for that symbol. Any symbol can be dynamically bound. Any symbol can be looked up dynamically. But only some symbols are set so that they're automatically looked up dynamically or bound dynamically just by referencing them. And that's what the global proclamation does.
And that's when you should use earmuffs. Please use earmuffs.
Please use earmuffs for def bar and def parameter. I mean, that's
because otherwise you run into nonsense like this and it's confusing.
Yeah. Final question. I do apologize for going over, but this is very, very interesting discussions going on.
Sorry, that was my fault.
No. This is great. Someone posted this question, which I know the answer to, but I'm going to let the discussion go anyway. Is it possible to implement a parentheses-free DSL in Common Lisp?
Sure. Why you would want to is beyond me, though. I mean, reader macros exist.
Yes.
We have things like...
What do you mean when you say a parentheses-free DSL?
I'm assuming they mean that an algol-like syntax.
There exists such things. There's C implemented in
Sweet
Lisp.
expressions. There's sweet expressions, for example.
Right.
Which is a white space-based syntax. Yes, you could. The real question is, in my opinion,
should you?
Would that really still be Lisp? I guess it is just a DSL, A. B, are you talking like actually at the parser level or at like a regular macro that just happens to not use parentheses? Because loop is like that. Loop is a macro that just doesn't use parentheses in its body, right? You know, and that's perfectly fine. So loop is literally an example of a Lisp DSL that doesn't use parentheses. The whole loop form has to be wrapped in parentheses, but and any subforms in the loop body have to be wrapped in parentheses, but the loop's grammar doesn't use parentheses to denote anything. And actually, quite a few Lispers find this a really irritating property of loop, myself included in some situations. Partially because it makes it hard to auto-indent. Like, really, really irritatingly hard to auto-indent. And I would imagine that the auto-indent algorithm for the loop macro is probably one of the most complicated bits of code in the Common Lisp indenter in Emacs.
So his response is, I guess, at the parser level is what he's asking for. And then yes, because that's
reader macros.
That's reader macros. Reader macros allowed you to essentially change non-Lisp syntax into S expressions that can then hook into the rest of the Lisp machinery to compile.
So a reader macro generates the data structure corresponding to Lisp code by parsing the source text directly. Right. Every macro's job is to generate some Lisp code data structure, right? And a reader macro does it by parsing the source text directly. And actually, most of the language itself is implemented using reader macros. OpenParen, for example, is a reader macro in Common Lisp, at least. And you could write a reader macro that generates the Common Lisp code data structure using a syntax that doesn't use parens if you wanted to. Doing that in a way that's just as expressive as the rest of Lisp and doesn't involve a lot of awkward hacks to make it like fully featured is really tricky. Sweet expressions are an example of that, gone reasonably well, but they're white space based, which isn't necessarily a downside depending on your opinion of white space based syntax. But
that's the Racket library?
It's got an implementation for Common Lisp, if I remember correctly, but yes, it was originally implemented as a library for Racket, I think. That sounds right. And I actually find it kind of a neat syntax. I'm probably never going to use it just because I write Lisp code to be consumed by other Lispers. But I think it's a neat syntax.
Barry,
it's
I
Even,
encourage
even if
you.
it's just for yourself, I mean, why would you want to? Because then you lose all the benefits of structural editing.
Right.
Sure. Oh, I mean, a lot of people who are new to Lisp, don't get a lot of benefit out of structural editing though, because it does take a lot of practice to get used to the mindset. But it is rewarding. For the record, anyone listening, structural editing is very rewarding once you get used to it, and it does not actually take a whole lot of effort to get the hang of. But it is weird at first, and it does take a kind of reworking of your brain to get used to. But yeah, so when you're just getting started, it can seem really awkward trying to get used to structural editing. I remember this from experience and from my experience teaching a lot of new people Lisp. Probably the thing that takes people longest to get the hang of, in my experience, learning to write Lisp is writing using structural editing commands. And from that perspective, it kind of makes sense to use a syntax that doesn't require structural editing to really be ergonomic. But at the same time, like, structural editing has advantages. It's not just like the thing we use to make writing parens comfy. It actually makes writing a lot of code like easier and safer in a lot of cases, because it's much more semantic. It's much more tied to the structure of the code that you're trying to write, as opposed to just characters on a page.
Yeah, it forces a consistent style.
Also true, yes.
That normally you'd have to kind of agree on when you're using other languages that are not like even like white space based, because white space based kind of forces you to actually do a particular style.
Or space indentation.
True. I encourage folks listening in, and Barrios in particular, who asked this question, for you to check out our videos on macros, because we've actually gone through some of this in fairly sufficient depth. If there's any particular questions that you have after watching those, feel free to post them on the YouTube channel and those particular videos, and we'll have another one of these periodically so that we can answer your questions. But that's it for this week. Next week, I'm hoping, knock on wood, my copy of AMOP will come in the mail, and we can actually get started on reading through AMOP. But if not, I'll let you guys know before Saturday what the next topic is.
Okay.
I'll see you guys next week.
Sounds good. Thanks.
Bye then.
Bye.